Assalamu alaikum wa rahmatullahi wa barakatuh, and welcome to another edition of our Matric Revision program. Today we'll be focusing again on mathematics, looking at paper 1, and our special guest Sandra Dixon, BSc from University of Stellenbosch, with maths up to third year. And she'll be joining us again to once again take a look at paper 1. Last week we started off delving into this paper, and of course, due to time constraints, we weren't able to go as far as we would have liked, but of course we hope that you will take some benefit from this show. And do be advised that we're not broadcasting on FM, we are streaming live on our social media platforms on Facebook and on YouTube. So if you are not able for any reason to get the entire video or watch the entire live video, you're welcome to go back to the videos on YouTube and Facebook. They'll remain there, and of course we will be streaming the various other subjects throughout the week as well for your benefit, so that you can get engaged with the content, you can engage with it, and that you can benefit from it. And also do be advised that during the stream you can comment on the show, and you can comment if there's any questions you'd like to ask Sandra or any of the other tutors that are on with us during these programs, and they would be more than happy to answer those questions. And of course also when we are streaming these programs, it's an opportunity for you, if you are looking to get a little bit more detail on these subjects, we have the visual available for you, so you can pause the video at any time if you want to screenshot any of the slides that our tutors put up, which helps make the learning experience a little bit more engaging, and also allows you to get as much detail out of the lesson as possible, and as much benefit as well. Well, allow me to greet my guest today, your tutor for the next hour, Sandra Dixon. Sandra, good day and welcome once again. Sandra, I want to say thank you for joining us, and of course today again looking at maths paper 1. So without further delay, with the time that we have, I'm going to hand over to you to proceed with today's lesson, still looking at obviously paper 1.
Thank you very, very much. Okay, so shall I go ahead?
By all means.
Okay, we are still busy with paper 1, the November 2020 paper that the matriculants wrote last year. I'm still giving tips and answers, so I am not restricting myself completely to the paper. However, I do cover the questions in the paper, but I also try to give information around the questions and attempt to do a little bit of revision. So today it's going to be sequences and series. And if there's more time or a little bit of time left at the end of this hour, I will also do an introduction into functions, more specifically how to draw a hyperbola. Right, so without anything further to do, let's jump in. Now, the revision here is about sequences and series. Now, some of you may still wonder, what is the difference between a sequence and a series? And it's rather important to know this difference. Now, a sequence is what we've done from grade 7 right up to grade 12. And that is when we write a sequence as, for instance, the one I've got up on the screen, a 7 semicolon, 10 semicolon, 13 semicolon, 16 semicolon. Now, important are the semicolons. And of course, it goes right up to n, and n means it's the last term in the series, in the sequence. We can also write it as a series, and then we add it in summation format. So we are, the way we do it, it is like a running total. So this sequence would become 7 plus 10 plus 13 plus 16, and so on and so forth until we get to the last term. Now, important, I'm starting off looking at the arithmetic sequence here. Now, that means that it's got a common difference. Now, this common difference is also known as D in the formulae that we have. So the formula that you will find on your formula sheet because I'm again referring back to the formula sheet. So there's no reason that anybody can forget any of the formulas attached to the sequences and series questions. So to generate the formula for a sequence, an arithmetic sequence in this case, would be Tn. Now, important, Tn in itself means formula. And the little n at the bottom points to the n in the formula on the right-hand side. So, argument's sake, if we need to get term 20, we would write t and at the bottom a 20. And when we use the right-hand side of the formula, the n would be replaced with a 20. Now, this we were all quite familiar with up to grade 11. In grade 12, they added the summation. And I've added the symbol in there because I've seen very often that the minute the learners see this summation Greek symbol, they, in quotations, switch off. Now, you shouldn't. It is just basically another way to write 7 plus 10 plus 13 plus 16 in a shorthand manner. Now, there's another formula attached to this. And please note, this has got an S, which stands for sum, or the Greek symbol for summing up a series. And this formula is n over 2 square bracket, and important now, 2a, because very often you forget about that 2 in front of the a, because this formula is so similar to the Tn formula. So important, note the 2a, and then the rest plus n minus 1, and I unfortunately left the d out. So please insert a d. So the formula should read Sn equals n over 2, open bracket, 2a plus, open bracket, n minus 1. Please insert a d, close square bracket. Now, in short, this can also be written with that summation symbol. And at the bottom, we have k equals 1. Now, that tells us where this series starts. And n tells us where it ends. And of much more importance is this Tn on the right-hand side. So that means that the formula to generate the series is this Tn. Now, we may wonder about all the little letters there. So A would be the first term in the sequence, N, the number of terms, and D, which I already mentioned, is your first difference if we are working with the arithmetic sequence. Now, very important is the yellow at the bottom. And many of us miss that. And please spend some time with it, because questions very often are based on this way of writing a sequence. So if you write it out, we can start off with the first one, which is A. And we would get the second one by adding the difference to it. So that is why we have A plus D. The third term we will get by taking the first term and adding the difference twice, which would give you A plus 2D. And so it will carry on till you get to the last term, which would be A plus, open bracket, N minus 1, close bracket, D. And this is also very important if you need to do the proof for the Sn, for the summation, because that is one of the proofs that you should know. Right, let's look at question 2.1 in the paper. And again, to repeat, this is the November 2021 paper 1. So this little question looks harmless, and it says, we have a sequence 7, X, Y, and then minus 11. And they tell us it's an arithmetic sequence. So you need to read carefully, because if they don't tell you, you need to determine what type of a sequence it is. And you know that there are 3 types of sequences. The arithmetic that we are dealing with here. Then there's a geometric sequence as well as a quadratic sequence. So those are the 3 types of sequences that you need to know very, 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 very well in grade 12. And in this case, the question is to determine the values of X and Y. Now, in dealing with this question with a couple of learners in the past, some get the answer without even using any rules. However, let's do it with the mathematical rules, because you won't be that lucky to get such a simple arithmetic sequence necessarily again in a paper. So I've written it out: 7, X, Y, and minus 11. So now immediately you need to see that we have A. A is your first term, so A is 7. And then we have the fourth term, which in yellow is A plus 3D, and we know it is minus 11. So quite simple, we know what A is. A equals 7. So we would put the 7 in the place of the A, plus 3D equals minus 11. Then 3D equals minus 11 minus 7. 3D equals minus 18. We divide by the 3, and D would be equal to minus 6. So now it is easy to find X, because X is A plus D. And if you wonder where I got this from, have a look at the previous slide, and you will see it is the yellow at the bottom of that slide, and you need to memorize this. So A plus D would be 7 plus, in brackets, the minus 6 of the D that we just calculated. So X would be plus 1. And the Y would be the third term, T3, which is equal to A plus 2D. And note that it's slightly out of step. It is the third term, term 3, but we use a 2 in front of the D. And if we work that out, we will get that the Y is minus 5. As I said when I started, one can get the answer here by inspection, or you could have set up simultaneous equations. So there are quite a number of ways to get this answer, but it is important that you guys understand how to use the way of writing the sequence, which is A plus D, A plus 2D, and know how to work with it. Right, let's carry on. Question 2.2. Given the quadratic number pattern, so again they tell us what type of a number pattern it is, so you don't need to test to find out what it is. So it's a quadratic. And they want the general term of this pattern in the form T, small n, equals an squared plus bn plus c. So this is a classic quadratic formula. And I just want to add in here as information to the rest of the paper. Grade 12 mathematics is based on largely a quadratic formula. So you guys need to understand what a quadratic formula really is, so that you can recognize it and know how to deal with it. Now, the way to recognize it is that there's normally 3 terms, but sometimes the middle term is not there. Then it's still a quadratic equation. And a quadratic equation basically has got something squared in the first term, and then in the second term, that variable n, its exponent will be half of the one in the first term. So in this case, it is n squared, the exponent is 2, and the exponent in the second term to the n is 1, which is half of the 2. Because it is difficult to recognize this if you have fractions as exponents. Right, let's get back to the question. So the first thing we would do with any sequence is determine what it is, and then write down the first differences, and if it's a quadratic, we need to go up to the second difference. So we obtain that, and it's very important. Don't just look at it and think the difference between 6 and 3 is 3, right? Take your calculator and take the second term, the 6, minus negative 3. And it actually becomes positive 9. Because many of you guys, especially if the nerves are sort of eating at you, you just look at this and you would say the difference between 6 and 3 is 3, and you would write down a 3. So for this, use your calculator. The second one in the first difference sequence would be obtained by saying 27 minus 6, which would give you 21. And the third one would be 60 minus 27, and that would give you 33. And now it's important to know that this forms an arithmetic sequence, because there are plenty questions around this fact that the first difference in a quadratic sequence is actually an arithmetic sequence. Then we proceed to the second difference, and now we would do 21 minus 9, and you would get 12, and you would do 33 minus 21, and you would get 12. So if you do this to a number sequence, and your second difference is the same, it is a quadratic sequence. If you have a sequence and your first difference is the same, like the previous question, then it is an arithmetic sequence. Now, something you need to learn, and it took me years to remember this, to now find the formula for this sequence, and by formula we mean it's some equation that would generate this sequence for you. So after you've done this that I'm circling at the moment with my cursor, you would on the left-hand side or right-hand side or wherever you feel comfortable, write these following yellow blocks. So you would write a 2a next to the 12 because it relates to the first term of the second differences. How I remember this next one is I'm adding 1 to the 2a, and I would get 3a, and I would bring in a b. And that relates to the 9, which is the first term of the first difference. And the top one is easy to remember. That is a plus b plus c. Now again, for those that struggle with this little a, b's, and c's relate here at the top to the a coefficient in front of the 9 squared. the B coefficient in front of the N, and the C is the third term of your trinomial. So that is what this little A, B, and C means, because it relates directly to the stuff in the yellow blocks on the left. So now it's plain algebra after this. I said before the 2A relates to the 12. So we set up an equation and say 2A equals 12. We divide by the 2, so A would be 6. Then we use the second yellow block. And we would say 3, and we would substitute the 6 of the value of A plus B, which we don't know, equals to 9, which is the first term of the first differences. If we do the algebra, 3 times 6 is 18, plus B equals 9. So B would be 9 minus negative 18, and the answer would be B equals negative 9. Right, so now we have A and B. Let's find C. C says you can calculate it if you have A and B up the first yellow block. We do have A, we do have B, we need C. So let's set up the equation. So 6, which is the value of A, plus negative 9, which is the calculated value of B, plus C equals negative 3, which is the first term of this sequence. If we simplify this, we will get negative 3 plus C equals a negative 3. So C would be 0, which means that there is no C term in this trinomial. So our answer would be, because I asked for it at the top, in the format Tn equals An squared plus Bn plus C, we need to answer it as, in yellow at the bottom, Tn equals, we replace the A with a 6, so 6n squared, minus, we replace the B with a negative 9, so it would be minus 9n. So that is the question answered. And I trust and hope that I've explained to you guys how this works. There are other methods as well, so you don't have to use this method if you were taught a different method. But this method, to me, as I've looked over the years, looks like the simplest one of the lot. Right, now we need the value. So question 2.2.2 flows from question 2.2.1. And again, an important note. The grade 12 question papers are set up in such a way that the questions very often follow on each other. So very often you need to use the answer of previous questions as input to questions later on in the same question. So just to make it simple, we just calculated the formula or the Tn on the previous page, and it came to 6n squared minus 9n. So that formula would generate that sequence. I said before that the small n on the side of the T relates to the n on the right-hand side. So if we want term 50, we replace the n with a 50, and we replace the n on the right-hand side with a 50 everywhere. And I've got an equal sign. It should be a negative over there. Where I'm circling now, it should be a negative. So we would have 6 open bracket 50 close bracket squared minus 9 open bracket 50 close bracket. And if we work that out on the calculator, we will get 14,550 as an answer. So that means if we wrote out that sequence, the 50th term's value would be 14,550. There we go. I fixed the slide up, so the error is gone. Now, question 2.2.3. Show that the sum of the first differences of this pattern can be given by Sn equals 6n squared plus 3n. Now, I fully understand that learners have a problem understanding this question in the first place, let alone doing it. That is why I took a lot of care earlier to define what n is, and now a keyword here is first differences. Now, the first differences in a quadratic sequence, remember that's what we're busy working with, is an arithmetic sequence. So if we have no idea what to do around this question, and the only thing we recognize is the S little n, and we know this is an arithmetic sequence, we will go to the formula sheet and write down the formula for the summation of an arithmetic sequence. So don't get confused. We are working with a quadratic sequence, but I'm just stressing here that the first differences make an arithmetic sequence. So we are using the formula n over 2 square bracket 2a plus open bracket n minus 1 close bracket d square bracket. Now we know the first term is 9. And the d equals 12. Remember when we started with the question? The sequence was -3, 6, 27, 60. But the one we are working with now are the first differences. And that is, let me just go back, is we're working with this one, the 9, 21, 33, of which the first term is 9, and the d for this sequence is 12, because 21 minus 9 equals 12. 33 minus 21 equals 12. So now we can substitute the a with a 9, which is the first term, and the d with a 12. And now we need to do some algebra, which I'm going to explain, because I find many learners that get this far and then they botch up the actual algebra that follows. So if we simplify, we first get rid of brackets. We've put in brackets, so we get rid of the brackets on the inside. So we will have n over 2 square bracket, 2 times 9 gives us the 18, plus, and now we need to multiply the 12 with the n, which gives us 12n, minus 12. We simplify this, and we get n over 2 square bracket 12n plus 6. 18 minus 12 gives us 6. Now we need to multiply the n over 2 into this bracket. And I've painstakingly written it out. So it means n over 2 times 12n over 1. And I strongly suggest that whenever you work with fractions, that you use this little crutch, this little one that I'm circling here at the bottom. So we would multiply the n by the 12n plus, and now this n over 2 needs to be multiplied with a 6. And if we simplify this, the 2 divides into the 12 6 times, and the n times the n gives us an n squared. So that gives us 6n squared, plus the 2 divides into the 6 3 times. N times 3 is 3n. And voila, there the question is answered. It looks like a foreign, pretty difficult question, but it was basic if you followed basic rules. In other words, don't think that you have to invent answers. Follow the basics. And what you recognized in the question was the Sn. And we have formulae for it. So that is how one would go about it. Now, question 2.2.4 is quite a strange question. So I'm going to go over it. There's a number of ways of doing this. Let's read it out. How many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21060? Now, this is really a mouthful, but let's unpack it. What are we looking for? We're looking for the number of the term n, which has the value 21060 in the quadratic sequence. Now, it says how many consecutive first differences were added to the first term. Now, the first term in the quadratic sequence is -3 plus the sum of the first differences until we get to 21060. Now it's algebra again. 6n squared plus 3n. We just obtained this in the previous question. Remember, the questions often follow on each other? And they gave us a tip with the previous question to actually get a formula for the first differences of the arithmetic sequence. So we replace the Sn with a 6n squared plus 3n, and I've taken the -3 to the right-hand side. So please note, now it is 21063 because it was added on this side. Because it's a quadratic equation, that little 2 tells us we're going to get 2 answers, and we need a 0 on the right-hand side. Very, very important for your other questions in both paper 1 and paper 2. So if you get anything that looks like a trinomial with a squared, we need a 0 on one of the sides. So we end up having 6n squared plus 3n minus 21063 equals 0. For a problem with such a large number here, we will use the formula. We could have divided 3 into here, but the result is still a big number here. So let's use the formula. And that formula, remember from my previous lesson, is the very first formula on your information sheet. And it is minus b, b being 3. So it's -3 in brackets. Please put the brackets. Plus, it's actually plus minus, but I use the plus and thereafter the negative. So the formula continues, square root, b squared, which would be 3 in brackets squared. Again, the brackets are very important if 3 was a negative number. minus 4a, which is 6, and c is negative 21063. Remember to take the negative with. All divided by 2a, and a is 6, so 2 in brackets 6. And if we put that in our calculator, we would get that n is either 59, and if we replace this with a negative, n would be negative 119 over 2. Now, n cannot be a fraction, nor can it be a negative number. So this is cannot be the answer. So n is 59. So this means that the 59th term of the first differences will be 21060. If you want to test it, substitute this 59 up here into the 6n squared plus 3n, and your answer will be 21063. But this is a little bit of a level 4 question and quite clumsily put. So I can understand if learners had a problem answering this question. Now, question 3. Now, here we work with that summation. Now, first you need to understand, what does it mean? How do I read this? So the question is, prove, right, that if I sum a sequence 4 dot, and that dot means times, 4 times 3 to the power 2 minus k, and we start with the first term, the k equals 1, and we end at infinity. So immediately that infinity will point you to the infinity equations on your information sheet. Now we need to prove that this is a convergent geometric series. And they want to see all your calculations. So if you look at your information page, you will see at the right-hand side where you have S with a foot infinity. To the right of that, you will have something that says minus 1, less than r, less than 1. Now, this is what you need to use if you need to prove convergency. So what does this mean? If r is greater than minus 1, it means it's a negative fraction. And if r is less than 1, it means it's a positive fraction. So in other words, we need to show that r for this sequence is a fraction. And important how you read this. So I'm going over it again. It says, if we sum, that is what that sum, that sign means. This Tn, this is a sequence, Tn, and we start with the first term and we go up to infinity. We need to show that it's converging. Now, up to now, in the first couple of questions, we had the sequence, they gave it to us. Here we have a formula. We have the Tn, but we do not have the sequence. So use your calculator and type in 4 times 3 to the power 2 minus, and in the first instance, k is equal to 1. Like I'm showing you there. So if we do 4 times 3 to the power 2 minus 1, the first term would be 12. And remember, please, that 12 was not obtained by timing 4 by 3. That 4 has got nothing to do with that 3. So please, either I call it a soccer ball or a huge multiplication sign, because this 4 has got nothing to do with that 3 over there. If we do the same thing with k, the second term, k would be 2. So we would say 4 times 3 to the power 2 minus 2. So the second term is 4, and we then substitute 3 into the k, the third term would be 4 over 3. That one wasn't really necessary because they're telling us that it's a geometric series. And with a geometric series, we now have a R. And we obtain the R by dividing the second term by the first term. So we would have 4 divided by 12. Or we could have done 4 over 3 divided by 4. But your answer will be 1 over 3. Because R is your constant ratio in a geometric series. And now we see immediately R is a fraction. So we got to our answer. But they said, show all your calculations. So you need to show them that this third fits, it makes this equation true. And because it fits in here, the series is convergent. So argument's sake, if this turned out to be a whole number, like a 2 or a 10, it would not make this equation true, and the series would not be convergent. Okay, but in this case, we had to prove that it was convergent, so we needed to show that R was a fraction. Right, now question 3.2. Again, to do it properly, you need to understand what is written here. Yes, they're looking for the value of P, but it looks awfully complicated. So this, to read it properly, it says, we are summing a series. We're starting at P, and we're ending in an infinity. And this is awfully a lot like question 3.1, but this time they tell us, if we sum all these terms, we will get an answer of 2 over 9. So what it means, we've just shown in the previous question that it's a converging series. So it converges to 2 over 9. So if we add up enough of these terms, the answer will be 2 over 9. Now, in the previous question, we used the formula that has to do with convergency. But to the left of that formula is another one, and it's got S, and at the bottom to infinity equals A over 1 minus R. We are using this formula because we are working with a converging series. A is still your first term, and R is now the constant ratio, which we determined in the previous question as being a third. And we wrote out the series, but very important, here comes the catch. A, your first term. Where do we get it now? Because if we put the physical first term in, there's no P to solve for. So remember, K starts at P. So your first term is actually 4 times 3 to the power 2 minus P. And if you did not see that, you would have had a big problem answering this question. And that is how they trick us. All that they did is they replaced a 1 with a P, because in the previous question, the P was a 1, and we entered the 1 in the case place to get the first term. I hope you guys see the catch in this question. So let's go through the algebra here. So we will say 2/9 equals, your first term is 4 times 3 to the power 2 minus P over R, 1 minus R, which would be 1 minus a third. All I did now is I calculated 1 minus a third. So the second step here, everything is the same except there's a 2/3 here, which is the answer to 1 minus a third. These arrows show cross multiplication. Now remember, we can only do cross multiplication if there's an equal sign. If there's anything else, you cannot do it. Now this means to solve this horrible thing, we multiply the 2 by the 2/3 on the left-hand side, equal 9 times 4 times 3 to the power 2 minus P. So that is a quick way to do a local lowest common denominator. If we simplify this, we get 4/3 equals, now remember this 9 and the 4 goes together, but stop at that dot. So it becomes 36 times 3 to the power 2 minus P. We want to solve for the P, so we need to get rid of this 36. Because remember, in exponents, your base and the exponent are glued together. You can only separate it by doing a very specific operation. However, this 36 has got nothing to do with the 3 to the 2 minus P. So we would have 4/3 divide, because this 36 is multiplied on this side. So if we go over the equal sign, you do the opposite. So it's divide by 36. And now we have 3 to the power 2 minus P by itself. If we put this into the calculator, we would get 1/27. So just for, again, making sure that you guys don't get it wrong, 1/27 written into prime factors is 1/3 to the power 3. We take the 3 to the power 3 to the top, and it becomes 3 to the power -3 equals 3 to the power 2 minus P. Very important to understand how we got here. Now we've got the bases the same, so we can discard them. So we end up with -3 equals 2 minus P. And now it's simple thereafter. It's a linear equation, so we will have only one answer. So P would be equal to 5. Right, so I spent a lot of time explaining the calculation around this, but you need to master it, because this type of calculation will always be part of your geometric sequence questions. Okay, so now we've completed the questions of the 2020 paper on sequences and series, And I can see, how are we doing for time on that side? Okay, I can probably still carry on. Let's have a look at question 4. Now, question 4 is a question that should not catch you out. Yes, in grade 12, you don't expect such a basic question. However, it is there in every single paper, and that is to draw a function. So this time we have hx equals minus 3 divided by x minus 1 plus 2 on the right-hand side. Now, first of all, when you need to draw a function, identify what the resultant function or drawing or sketch must look like. Now, this one is a hyperbola, and it's a hyperbola because your x is below the line. So if you want to know what type of a function it is, you need to look at the position of your x in your equation. Right. So it's a hyperbola, and we're expecting a graph looking something like this, which is not the graph that's up there. It is just sort of how we would expect it to look. Now, very important to see that there's a negative sign here. So if your hyperbola has a negative sign, your graph would be in quadrants 2 and 4. Not the way it's depicted here. It would be in quadrants 1 and 3 if that was a plus. Now we need to know that a hyperbola has 2 asymptotes. And that is what distinguishes it from other functions. And the only other functions that we have is a straight line, a parabola, the third one a hyperbola, and the fourth one an exponential function. Those are the 4 that you need to know backwards, and you must be able to draw them. Because if they don't ask you to draw a hyperbola, they may ask you to draw an exponential function. So what distinguishes a hyperbola from the other functions is it's got 2 asymptotes and it's got 2 mirrored halves. The asymptotes are normally shown with dotted lines. Again, if we go back to this little sample here, now there's no dotted lines. So in this graph, the asymptotes would be your x-axis and your y-axis. And the formula for the x-axis is y equals 0. And the formula for the y-axis is x equals 0. Very important to know that. But in this case, let's see, where are we going to find the asymptotes? I've got one in yellow and one in brown. Now with the functions, the term on the right-hand side normally has to do with the y-axis. So we would now have a horizontal asymptote cutting the y-axis at 2. So the formula for that would be y equals 2. The x one is easy. So the x, obviously it has to do, or it must have to do with the other asymptote. And this is the vertical one. Now, when we read any equation, that has a division line like that, we must assume brackets around the bottom stuff. And if we set this to 0, the x becomes equal to 1. That is why the other asymptote is at x equals 1. Note the change of the sign when you take it out of the bracket. But here, the sign remains positive. So right, so now we've answered question 4.1.1, and we've given the equations of the asymptotes of h. And hopefully, we now know what the asymptote is. That means it's a dotted line or an area where the graph cannot cross. So now the next question is, determine the equation of the axis of symmetry of h that has a negative gradient. So the axis of symmetry, I'm just going to go back to the previous slide. The axis of symmetry would cut the graph in two mirror images. So the one would be here. That would be the axis of symmetry with a positive gradient. And we can also cut it like this into two similar or exact mirror images of each other. And that would be the symmetry axis with a negative gradient. Now, this is some learning. So if you want to find the answer to this question, you'll find it in the part of the equation that I've marked in yellow here. So basically just circle that, your axis of symmetry. So you would write it down, y equals plus minus, plus for the positive one, the negative for the axis of symmetry with a negative gradient. And we would put this in brackets because I already told you, you must view that as if it's in brackets, plus 2. So the axis of symmetry with a negative gradient, we would take the negative sign. So it would be y equals negative x minus 1 plus 2. If we multiply the negative into the bracket, we would get negative x plus 1 plus 2. So the answer would be 3. Okay, so the axis of symmetry that has a negative gradient would be y equals negative x plus 3. Now let's draw this graph. And sorry for my shaky graph on the right-hand side. I still need to find a way to make it smooth. So if we sketch this function, this parabola, this hyperbola, we need to find the y-intercept and we need to find the x-intercept. But we normally start with the asymptotes. And we've already, in the first question, said that the horizontal asymptote is at 2. Y equals 2. And the vertical asymptote is at x equals 1. So we would put that onto the graph first. Because of the negative, we know that our halves of the hyperbola must be in the second and fourth quadrants. And normally when we draw it, we start near the one asymptote and bend it towards the other one. Start next to an asymptote and bend it towards the other one. but we need the X-intercept and the Y-intercept. So let's calculate it quickly. So if we want the Y-intercept, we have to set the X to 0. And remember, guys, this is the same for all the functions. So if we set the X to 0, it becomes minus 3 over 0 minus 1. And if we work this out on our calculator, we'll get the answer 5. Jeepers, I must have been sleeping last night. That must be the 5, and this one has to be the 2.5. Okay, so your X-intercept is 5, and we need to calculate it. We cannot guess it or find it any other way by calculating it. And if we want the X-intercept, we set the Y to 0. So 0 equals minus 3 over X minus 1 plus 2. And we need to solve for X, which again is a difficult calculation. So we start the furthest away from the X, and we move the 2 to the left-hand side. And like in the first or the previous question where we did cross multiplication, we do it again. So minus 2 times, open bracket, X minus 1 equals minus 3 times the 1 here at the bottom. We multiply it out, so we end up getting minus 2x plus 2 equals minus 3. So minus 2x equals minus 5, because this becomes a negative on this side. So minus 3 minus 2 gives us minus 5, and we divide by a minus 2. So x equals positive 5 over 2, or 2,5. And we insert those numbers, because when they mark this question, they will give you a mark for the X asymptote. For the Y asymptote, that's 2 marks. 3 marks for the Y-intercept, and another mark for the X-intercept. Because that question, let's see how many marks it was. Yes, 4 marks, and that is how they would give you the marks. For the 2 asymptotes and for the 2 intercepts. And these are marks that you cannot afford to lose. So please, when you revise, make sure that you can sketch a straight line, a parabola, a hyperbola, and an exponential graph. And that's all for today. I hope you enjoyed the lesson and that you would be fit to answer more questions along these lines.
Sandra Dixon, I want to say a big thank you. I think we've covered a lot of ground in this session of Paper 1. And of course, Sandra Dixon is a BSc from the University of Stellenbosch. She has maths up to 3rd year. And of course, she is giving extra math lessons for learners grade 8 to 12 and one-on-one teaching to improve learner results. If you want to get in touch with Sandra, Sandra, an email that people, WhatsApp that people might be able to reach on?
The best way to find me is to send questions on the video, or my email address is Sandra Dixon, one word, DICKSON 67 @gmail.com.
Fantastic. So that's Sandra Dixon 67 @gmail.com. If you'd like to get hold of Sandra and you'd like extra lessons, I want to say thank you, ma'am. A big thank you for this extended session. And of course, if you would like to go back and check out the full video, you can do that. It will be up on our social media. Well, from myself, Mohammed Fasih Peterson, till we link up once again, we do this tomorrow. I bid you assalamu alaikum wa rahmatullahi wa barakatuh. And yeah, look out for our next matric revision video.